In this lesson, we're going to look at Pythagorean Theorem. And there's a couple of things that we'll sort of skip over the first part here. There's an investigation, as you can see, and feel free to do it if it's a rainy day and you're feeling bored and you just want to dive into Pythagorean Theorem, then by all means do this investigation. It's self-explanatory here on this page. I'm going to skip past this, though, in the interest of time. Here also is a good introduction to who Pythagoras was. He was a Greek mathematician who lived, well, 2.5 centuries ago. And again, I'm not going to read that over, but feel free to read that. I just want to dive into the actual mathematics that we're going to use for Pythagorean Theorem today. All right. So Pythagorean Theorem allows us to find the third side of a right triangle if we know two of the other sides. So Pythagorean Theorem, first of all, is only for right angle triangles. It has to be 90 degrees in the corner. And we represent that with this. On this triangle here, you can see that little box in the corner. Well, that is what tells us if something's 90 degrees. You can see it on the other ones as well. Example 1, you can see the little box in the corner. I guess that's it for sketches, but when I draw my own, I'll put the box in the corner. That means 90 degrees. When we are doing Pythagorean Theorem, we need to think about the sides in a particular way. So we want to call them A, B, and C, like this. And C is always the hypotenuse, which is the longest side. It's also the side that's across from the right angle. So there should be no trouble picking out what the hypotenuse is if you're paying attention. Longest side, across from the right angle. Doesn't matter if it's spun around, like in example 1. Here's the hypotenuse here, longest side across from the right angle. It's turned around a bit, but this is still the longest side, and it's across from the right angle. So no reason not to be able to pick that out super quickly. Once we know that, then we can write the formula. It's turns out that a squared, so this side here, plus b squared, this side here, is equal to c squared, this side here. So if we square each of those sides, add the two shorter ones together, it's going to equal the longer one. Okay, so that's Pythagorean Theorem. And I could either write it a squared plus b squared equals c squared, or I could rearrange it or flip it, c squared equals a squared plus b squared, which might be more useful. So because normally if I'm looking for the hypotenuse, then remember that's c, hypotenuse is always c, then it's going to be, we want to have that by itself on the left-hand side. So that's one version. What if I'm not looking for the hypotenuse, though? Well, in that case, what am I going to do? I'll just do some rough work over here. Say I wanted to get a by itself. Say I was looking for side A. Well, then what I would do is I would subtract. I'd take this b squared over to the other side. And in fact, actually, I won't do it here because I can just do it right underneath. If I bring the b squared to the other side, then what I'm left with is a squared on the left, and I've got c squared still on the right, but I'm going to subtract the b squared. And so that's just a version where I'm trying to find a. Or I could find b by bringing a squared to the other side, right? So I could bring either one of these to the other side and still isolate to find them. Now, these two versions are really the same, because it doesn't matter which side we call A and which side we call B. They're just the other two sides that aren't the hypotenuse. So whichever side, whatever you call any side in your mind, as long as you're clear that the hypotenuse is the one you really have to keep your eye on. Keep it separate. So let's just do a couple of examples here. Find the length of the missing side. Okay, so we already established that C, that the longest side is the hypotenuse. I'm going to call that C. Even though it's already called X, I'm going to call it C just for formula purposes. I'm going to call this A, and I'm going to call this B. But I could have called this B, and I could have called this A, because it doesn't matter at all which one I call which. All right? So just be aware that that part doesn't matter. So I'm trying to find C. So which version do I want? Well, I want the version where C is by itself. I want this version here. C squared equals A squared plus B squared. Okay? Well, let's write it out. No harm writing the formula out again. But C is the same as x, right? So I'm going to use actual letters given to us. So x squared is going to equal 6 squared plus 5 squared, because A was 6 and B was 5. So that means I have to square 6, that's 36. I have to square 5, that's 25. Then I have to add them together, and I get 61. And I still don't have x isolated, though. I have to take the square root of each side. So if I square root this, I get x equals the square root of 61, which is about 7.8. And the units will be centimeters, because the units of the other two sides are centimeters, so it's always going to be the same units. In example B, the hypotenuse is given to us. That longest side is 12 meters. And then I can call this A and call this B, or I could switch to A and B, it doesn't matter. But in this case, I want to find what I've called side B. So I'm going to use that version there, right? Whatever I'm trying to find, I'll isolate. So B squared equals C squared minus A squared. Notice how there's a difference here. This one is plus, these two are subtract. So again, not hard, but some care needs to be taken when you're doing this. So if we're finding B, we're going to subtract A squared from C squared. So B was x, so x squared equals 12 squared minus 4 squared. 12 squared is 144, 4 squared is 16. So x squared equals 128. Take the square root of each side, and x is equal to 11.3. And again, the units will be the same as what was given, so it'll be meters in this case. Let's look at a word problem. 5-meter tall windmill is supported by 2 wires on either side. I think what they mean is 1 wire on either side, 2 wires altogether. 1 wire is 13 meters long. The distance between the 2 wires is 16.75 meters. Find the length of the second wire. Okay, what we need to help us with this is a sketch. All right, we need to visualize this. So I'm going to start by drawing a line to represent the ground. I'm going to draw another line to represent the windmill. And we're going to assume that the windmill is standing straight up and down, so it's making a right angle with the ground. And then it's got one wire on one side. So I'll just draw that like that. It's got another wire going to the other side. Those are my 2 wires, one on each side. So that's sort of what we're looking at. Now we've got some stuff that we can fill in here. The windmill is 5 meters tall. One of the wires is 13 meters long. Now this isn't necessarily to scale, so I'll just pick one and call it 13. The distance between the 2 wires is 16.75. So what they're saying is this. 16.75 is between here, those 2 ends. And again, meters. Now we're supposed to find out the other wire length. Let's call that x. So how are we going to do that? Well, what I see here is 2 right triangles. I see one that's here outlined in green. There's a right triangle, right? But here's another one outlined in orange. So these are both right triangles, and I can work with both of them. And even though I didn't put a box here, I can add that little box down in that green triangle to show it's a right triangle as well. So I want to find x. But I don't have enough information. If I want to find x, I need to find out what this side length is. I need to know what that side length is so I can use Pythagorean theorem. I don't know that, so that means I have to find that before I can find x. So let's call that something else. Let's call that y, and we know we have to find that first. Well, how am I going to find y? I know that the whole length is 16.75 meters, but if I knew what this one was, I could subtract that from 16.75 and I can get y, but I don't know that. So that's something else I guess I need to find before I can solve it for x or y. So let's call that one z. Z I can find because I already know the hypotenuse and I know this side here. So I can find z, I can use z to find y, and then I can use y to find x, and that's the way I'm going to do it. So Pythagorean theorem, here's my c, I'm going to call this a, and I'm going to call this b. So this is one of these cases where I need to find, I know the hypotenuse and I need to find something that isn't the hypotenuse, so I'm going to use this version. So it's going to be z squared equals 13 squared minus 5 squared. That's 169 minus 25 when I square them. And that gives me 144. And when I take the square root of each side of the equation, I get z is equal to 12. Okay? That's good. Now that I know that z is equal to 12 meters, then it's easy to find out what y is. It's going to be the 16.75 total minus 12, which is 4.75. And now I know both of the sides inside the orange triangle, and I can find the hypotenuse. Remember, x is the hypotenuse. I've already called the 5-meter height a, so I'll call this b. So I'm trying to find c now. C squared equals a squared plus b squared, which means that x squared equals 5 squared plus 4.75 squared. 5 squared is just 25. That's an easy one. You're going to need a calculator, though, to do 4.75 squared. It's approximately 22.56, if I round it a little. Add them together. I get 47.56. Take the square root of each side. And it turns out that x equals approximately 6.8 meters. So then, being a word problem, we write a sentence answer, right? The other wire is 6.8 meters long.